So we are going to look at trig forms of vectors. We're going to connect our vectors to the unit circle, and then we're going to be able to connect this to kind of the next thing that we do. So here we have a unit circle. We should be very well versed in unit circle stuff. And it says if u is a unit vector, meaning the length is 1, right? So here's u. It is a unit vector. The length is 1. The magnitude is 1. Then the terminal point of u, here's the terminal point right here. Since this is a unit of 1, it lies on this circle, which would make the radius of this circle 1, which makes this the unit circle. So this point here has the ordered pair AB, right? A is your x value, B is your y value. We know, because we are like unit circle experts, that the x value on the unit circle always represents what? Cosine. So my x value is actually cosine theta, and my y value is sine theta, right? So since I'm on the unit circle, that is cosine theta, sine theta, or AB. Make sense? Since that's what that ordered pair is, and this vector is in standard position, then it says, therefore, if the vector u is vector AB, which makes sense, then it can also be written as cosine theta, sine theta. And guess what? Magnitude, right? If I wanted the magnitude of that vector, the magnitude of u, remember from the other day, it's the square root of a squared plus b squared. So this would be the square root of cosine squared theta plus sine squared theta. What's cosine squared plus sine squared? 1. This is the square root of 1. The magnitude is 1, which we already knew. But see how that all works out? There we go. We could also write this as a linear combination. So linear combinations were from yesterday. So vector u is, I take my a, which is cosine theta, times I. We're going to do I hat. So I said a couple things yesterday. I was like, it could be I, like it's bolded. It could be I hat. It could be I, that's a vector. But I thought, we're going to go with I hat, so we kind of know that they're different, because there's lots of different ways to do it. Plus sine theta times j hat. So going from a linear combination to component form and vice versa, those are, pretty simple transitions there. Okay? And if you think about what our vector is, we have a magnitude, and then the direction is our angle. Okay? So it says, because every vector v is the product of its magnitude and its corresponding unit vector u, we can write v in the following form. So this is vector v, right? So that's the magnitude of v times a unit vector. So that means my unit vector I can write like this. So it's also the magnitude of v times cosine theta, sine theta in component form. I can distribute this, so this is like multiplying by a scalar. So I can make this into the magnitude of v times cosine theta, the magnitude of v times sine theta. Or as a linear combination. So linear combination from component form is super easy. That's just going to be the vector is, then that's going to be the magnitude of v times cosine theta I hat plus magnitude of v times sine theta j hat. What questions do we have? Anything at this point? Okay. So then our directions say, find the component form. Component form of a vector is your pointy bracket form. We're going to find the component form of each vector with the given magnitude and direction angle. So your magnitude is the length of the vector, or the size of the vector, right? That's like r. And then this is like r theta. It's the same thing. Just like this right here, r cosine theta, r sine theta, or mg cosine theta, mg sine theta, if you're thinking physics. So I have this. That means that for vector v, all I have to do is take the magnitude, which is 8, multiply it by the cosine of 60, and then 8 times the sine of 60. Okay, so let's do this one without the calculator. What is 60 degrees in radians? Pi thirds. Okay, so let's think, because I know we would all rather think in terms of radians. So this is going to be 8 times, so pi thirds, my hand trick, I'm right here, so the cosine is 1/2. And what is the sine? Square root of 3 over 2, very good. So then that means the vector is 4 square root of 3. What questions do we have? We good? All right. So then here, the magnitude of A, so I want vector A in component form. I'm going to take the magnitude, which is 30, times the cosine of 340, and then 30 times the sine of 340. 340 is not a special angle. Okay, so here's where I'm going to use my calculator. Make sure your calculator is in degree mode, whichever kind you're using. I'm going to do 30 times the cosine of 340. Since I'm using the kind of calculator where I can see each answer as I do it, I'm going to go ahead and type in both of them. So 30 times the sine of 340. So there are both of my answers there. And if it does not tell me how many decimal places I should use, how many do I use? 3 to the nearest thousandth. So those are my two values. That means that my vector A is, I never can remember once I switch over. So it's 28.191 and negative 10.261. And if you think about what this vector is, so the length is 30, and it could be 30 whatever, so the length doesn't really matter, but the angle is 340. Well, I know that 360 is right here, so my vector is going to be like somewhere over here. I don't care exactly where, but it's somewhere over there because it's almost at 360, which means that, and this isn't necessarily 0, 0, that's just helping me with my angle, so it's pointing towards the fourth quadrant, and this also going positive, and then negative would also be pointing towards the fourth quadrant, so I feel like I'm good. Okay? What questions do we have? All right, we're going to look at going the opposite way then. So it says, write each vector in trigonometric form. So here, I have it in component form. I want it in trigonometric form. So in order for me to get it into trigonometric form, the two things I need the magnitude and I need the angle, because I don't know those. But I can get those from the component form just like we did the other day. So for M, the magnitude of M is going to be equal to the square root of negative 3 square root of 2 squared plus negative square root of 6 squared. All right, so negative 3 square root of 2 squared. What is that number? 18. And I would highly suggest doing those without a calculator because a lot of times they don't get typed in correctly, and then there we go. So this is 18 plus negative square root of 6 squared is what? 6. So that is the square root of 24. Now, this is a CAMI assignment. It is not a Delta Math assignment, and I want you to simplify those square roots because, again, it's still a skill we need to have. So if I simplify that, what do I get? 2 square root of 6. Very good. So 2 square root of 6 is the magnitude of m. So I'm not done. It's not even, technically half of my answer, but I'm going to underline it so I can go back and find it in my work. I'm not going to box it because sometimes I get carried away and I just box everything, but just underlining it so I know that that's what I got to come back and look at. So the other thing I need is the angle. So theta, to find that, remember that was the tangent inverse of b over a. So that's negative square root of 6 over negative 3 square root of 2. So let's see if this is one we know. So tangent inverse, so this will become positive. The square root of 6 and square root of 2, and it gives me the square root of 3 over 3. That is one we know. Even though we want it in degrees, I know we think in radians, so we're going to write the radians down first. What's the tangent inverse of the square root of 3 over 3? Pi sixth, yeah, pi sixth. Okay, but I got to think about what quadrant I want. Okay, so if this is negative, negative, what quadrant am I pointing to? 3. So what is my third quadrant pi sixth angle? 7 pi 6. Okay, everybody with me so far? But I want that in degrees, right? I don't have to convert. All I have to do is reason and think around that unit circle. So pi 6, what's pi 6 in degrees? 30, okay? And I know I'm in quadrant 3, right? So I'm in quadrant 3 over here somewhere. And this is 7 pi 6. So I know I had to go 180 and another 30. What's 180 plus 30? 210. There's my angle. Okay. Everybody good so far? So now that I have my magnitude and my angle, I can write this in trigonometric form like I want. So my vector is the magnitude, which is 2 square root of 6, times the cosine of the angle, which is 210 degrees, and then 2 square root of 6 times the sine of 210 degrees. And I stop, because if I actually work that out, guess what I get? This right here. And I'm just going in circles, right? This is what I want. It looks like it isn't solved, and that's fine. This is my answer. Okay? Because we're trying to push it into that trig form. So now let's again think about what we have and what our answers mean. We know that if I have this vector, it's pointing towards the third quadrant like this, because it's negative, negative. There's no negative signs here anywhere. But in the third quadrant, is cosine positive or negative? Negative. Is sine positive or negative? Negative. So this does become negative, negative because of the cosine and sine values. Make sense? Okay. So these mean the exact same thing. We would draw the same vector. The vector has the same magnitude, same everything. They're just two different forms. Okay, we good with that? All right, so let's look at number 4. I have this in a linear combination, but I would really rather it be in component form to do everything. So this is super easy. Don't overthink it. What would the component form of this vector be? Negative 2, 2, exactly. Okay, there's my component form. So go ahead and find the magnitude. What does the square root of 8 simplify to? Very good. 2 square root of 2. So that is the magnitude of r. And I don't remember if this question was asked in this class or if it was later. I just know it wasn't in second period, so I'm just going to say this again because it wouldn't hurt for everybody to say it again. Somebody had asked me if we had to put the little lines around this, and the answer to that is yes, because this represents the magnitude and this represents the vector, and those are two completely different things. Okay, so I just want to make sure I've said that in every class and made that clear. All right, so then I need my theta. Theta is the tangent inverse of b over a, so that's of 2 over negative 2. So that's the tangent inverse of negative 1. All right. What's the tangent inverse of positive 1? Pi fourths. And since this is negative 1, this would be negative pi fourths, right? Okay, so that means it's a pi fourths angle. That's all I really need to know. What quadrant do I need my angle to be in? 2. I need a quadrant 2 angle. So my second quadrant pi fourths angle is 3 pi fourths. That puts me over here. What is pi fourths in degrees? 45. So that means I go 90 and another 45, and theta is 135 degrees. And I am well aware of the fact that if you do the tangent inverse of negative 1, your calculator will give you negative 45, and then you can figure it out from there. But, and that's fine. You can double check yourself that you're right, but you still have to have the ability to think around this circle. So the more we do that, the less likely we are to forget it all. All right, so they'll go ahead and write your vector in trig form now. That's what I got. Do we have any questions at all? Easy enough? So it's a lot of the same process that we did before, and it is your r thetas, or your mg thetas. Okay? All right, let's look at number 5 then. Number 5, I've given the initial and the terminal points, but not the vector itself. I would like it in component form. So I think I'm going to take the vector yz, and put it in component form. What do I do to figure that out? Yes, x2 minus x1. I'm going to subtract, and I got to make sure it's z minus y. That's why it's at x2 minus x1. Very good. So it's 5 minus 3. That'll give me 2. And then negative 8 minus a negative 2 gives me negative 6. So let's go ahead and think about our quadrant. Positive, negative, that means my angle needs to be quadrant what? 4. Okay. It's always good to think about it first. Sometimes I don't think about it until later, but just don't forget to think about it at all. That's the important thing. All right, go ahead and find the magnitude then. Magnitude of yz. You can do that without me for sure. What is the square root of 40 reduced to? Very good. 2 square root of 10. That is the magnitude of yz. Okay. Any questions at this point? All right. Let's find our theta then. Theta is the tangent inverse of b over a, so that's going to be negative 6 over 2. So that is the tangent inverse of negative 3. Is that a value you're expected to know? No, it is not. So here's where we go to our calculator, and I want to find the tangent inverse of -3. So tangent inverse -3 gets -71.565. So this equals -71.565 degrees, which I know for a fact is not the angle I want because it's negative, but this gives me a fourth quadrant angle, right? And I went this way. What quadrant do I want to be in? Fourth quadrant. But I want to be able to get there this way. So what do I do with this number? Add 360. Very good. So I can just do answer plus 360. That gives me 288.435. So theta is 288.435 degrees. Now, we normally don't mix square roots and decimals because like either it's exact or it's not, but this is one of the exceptions to the rule, because if we just, again, work everything out, we're going to end up right back here, and that's not where we want to be. So my vector yz will be 2 square root of 10 times the cosine of 288.435 degrees, and then 2 square root of 10 times the sine of 288.435 degrees. And there you go. What questions do we have? Anything at all? Okie dokie.